Hello again. I thought we would do a couple of hypothesis test questions, just a couple of simple ones to get our minds going. And we're going to start out with the mass production, and we're going to look at a component, and it's only going to work if it is between 6.2 and 6.3 centimeters long. And what they do is set the length between those values. So they have it set at 6.25, and the sigma is known to be 0.021 because there's always some variability. So the operator checks 100 components and finds a sample mean of 6.2516, and we want to test the claim of no difference between the mean of 6.25 and let alpha equal to 0.10. Okay, so in that one, we have our n equal to 100, referring to the 100 components. And even though we don't know what the distribution is, it doesn't matter because we have large samples. We know what sigma is. It is 0.021. Okay, and we know what our hypotheses are going to be. It's the equals, not equals. So we're going to have equals 6.25 versus not equal to 6.25. All right, everybody okay so far? Good job. Okay, so we're going to have our test statistic, and we'll use our, let me write down the formula. So we have x bar minus mu sub 0 over sigma over the square root of n. And the x bar is the value that he got from the sample. So that's the 6.2516. The mu sub 0 is the 6.25. The sigma is the 0.021. And the n, of course, is the 100. Now when you do your hand waving, I actually cheated and used R. And I'll show you what steps I used in a minute. I'll actually put that on the paper that's going to be attached to this. So when I did that out, I got 0.7619. Okay? All right, let's get a clean page. So we have step 3 where we set up our rejection region. And we know we had the not equals to, so that tells us how to set up our rejection region. So we know that we have the 2 piece one. So we're going to take 1 minus alpha over 2. And our alpha level was 0.10. So we're going to have 1 minus 0.10 over 2. And that's 1 minus 0.05 or 0.95. And here again I cheated and used R, and I will show you how to do that in the handout. And I got the value back for that. And it turns out to be 1.645, one of our favorites. So our if then is going to be if Z star is greater than 1.645 or Z star is less than negative 1.645, then we reject HO. Okay, because it's the two-sided one. All right, so our test statistic was the 0.762. So it's not greater than the 165 or 1645. It's not less than negative, therefore we will fail to reject. Which is good. We want those components to fit nicely. Okay? Good job. All right, let's go on to the next problem. So the next one, my pen is acting up. It's not mightier than swords. It's not mightier than anything right now. Here it goes. All right. So we're looking at exam scores, and sometimes they're scaled. So you end up with a mean mu of 500 and an S of 100. S. Normal. Okay, what does that make me think of? Okay, I've got a normal distribution. I've got S. I don't have sigma. It makes me think of the T distribution. Yes? Okay, so in a particular class of 25 freshmen, so I've got small samples, I've got S, I've got a normal distribution. I want to use the T distribution to solve my problem. Okay, so we have 25 freshmen. We have a mean score of 472. The professor wonders if he doesn't have a class full of little slackers. So he performs a hypothesis test, and he tests the claim that the mean score was less than 500. Let alpha equal 0.05. Okay, I was certainly sensitive on this one. All right, so I'm going to have mean mu greater than or equal to 500 versus mean mu less than 500. Okay? You don't care how high it gets, you do care if it's less. So in step 2, now remember you're going to have the T distribution. So you're going to have the X bar of 472 minus 500 all over the S of 100 over the square root of 25. And here again I cheated and ended up with minus 1.4. Obviously this is a textbook problem. Nowhere in real life would you ever come up with a number that good. All right. So let's flip to the next slide. In step 3, you find your rejection region, and remember this is the less than, so I'm going to look up T at alpha with n minus 1 degrees of freedom. So we're going to look up T at 0.5 with 24 degrees of freedom. Why is it 24? I had 25 students in the class, so it's n minus 1, 25 minus 1, or 24. So when I look that up, I get 1.7109. Again, I looked that up in R. And my if then is going to be if, excuse me, Z star, sorry, I lied to you. T star is less than negative 1.7109. Then we reject HO. Okay, because it's always going to be less than the negative. All right, so remember from the previous page, our T star was minus 1.4. It is not less than. Therefore, here again, we will fail to reject. Not interesting. That's all right, though. Okay. All right, I hope this gives you a good warm-up for hypothesis testing. And I'm tired tonight, but I will get you some nice new ones tomorrow with 2 samples and maybe even some of the ones out of the practices that we have out of the book, not out of the book, out of the web pages. Okay? Thanks. Bye.